right. Hi, my name's Albert Wong. I'm the developer advocate at CelerData. So CelerData is actually the commercial provider for StarRocks. Background is I'm a Java developer by trade. Worked a long time at Red Hat, worked a long time at MongoDB, and now I'm over at CelerData. So a little bit about what Celer means. Celer means quick in Greek. That's how we picked our name. And what we pride ourselves is that we're a high performance analytical database. We're fast on fast, right? So just three things to think about when you think about StarRocks, which is our open source OLAP database. High performance, we're able to go and in many cases be 3 to 5 times to 10 times faster in terms of query performance. There's a lot of little engineering tricks we did in order to make that all happen. We also support the ability to do joins on real-time data. That's I'll talk about that a little bit more. And we're very, very scalable. So we've got customers that actually are in the petabyte range that are using our database to feed their real-time systems. The other thing I'd like you to think about is that what we did as our open source strategy was that we adopted the MySQL protocol. So whatever you can do in MySQL, whatever products you use in MySQL, you can just instantly connect to our system and use those same type of tools. And the last thing is a little bit why we're called CelerData and StarRocks. So StarRocks is the open source project. We donated to the Linux Foundation all the trademarks and the IP. So as a result, we as a company can't call ourselves StarRocks anymore. And that's why we picked the name CelerData. So StarRocks is part of the Linux Foundation. You can see us up as one of the projects on the page. All right. So talking a little bit about use cases before I dig into a little bit about querying Hudi tables. So a lot of times when people are looking at our product, they're really looking around maybe on cases of real-time data feeds. Like this is places where we're talking about is, say, for instance, fraud analysis, security dashboarding, security alerting, ad bidding from that standpoint. Times where you need freshness of data, you need to go and look at current data along with historical data and get to a number, an actionable number from that standpoint, or actionable thing that you can go and do with that data. So in the case that we have, talk a little bit about Airbnb. Airbnb has their own metric platform. They basically store data in one of those table formats, right? And they use Druid, Presto, and Spark to basically query that data. As you can imagine, there's a lot of different metrics. There's a lot of different dimensions with the data. And it's very, very complex in terms of having to go and build various pipelines for all those pieces of data, right? And as you kind of know, products like Druid and ClickHouse are not necessarily very good at doing joins. And that's why you have to go and do denormalization. That is a strategy of denormalization since the 90s, right? Everybody kind of knew that in order to get speed, you kind of denormalize. So it's not necessarily a new idea from that standpoint, right? So with Airbnb, they tried that model of denormalizing everything, and then they used Druid, Presto, and Spark. We came on in with StarRocks. And the nice thing about it is because you don't have to go and denormalize tables, so they simplify their data pipelines, ability for them to go and handle concurrency, and they can get is less environment, less servers needed to go and constantly massages the data pipelines, right? Don't need that much anymore. Don't need as much infrastructure to go and support the query, the query patterns or the query loads from that standpoint. We've got a lot more information. I don't want to bore you with all the necessarily minutiae details, but if you search on our website on starrocks.io, you can find a YouTube video of where the Airbnb engineers talk about an hour about, their use case, why they, what they tried in terms of gaining performance, and then what they evaluate in terms of products, and then why they settled onto StarRocks. Right. So moving on. So what is StarRocks from that standpoint? I mentioned a little bit that we are an analytical database, right? Typically, people see us in three major categories, right? They either evaluate us as a traditional OLAP database, right? And this is kind of in the situation where we're like seen as like an open source version of Snowflake, right? Or Netezza, or whatever those traditional OLAP databases. And we can play in that space if you want to, right? The other use case that we have is providing warehouse-like capabilities on top of data lakes, right? So the idea here is that you leave your data at rest, you don't go and import the data, right? And maybe you are using Hudi underneath, or one of the other mentioned table specs on out there on this chart, right? You can use all those, you connect to it remotely, leave it in the data lake from that standpoint, and you use it as a query engine on top of all those other data formats, right? So that's a big other use case that we have. I would say that maybe half of our community users are in the data lakehouse space, right? I'd say a good portion from that standpoint. And then we have the last use case of real-time analytics, right? And this is where kind of where we focus our engineering at to be different from the marketplace. And what we mean by real-time analytics is here where you're ingesting data in real time. We're talking about here in sub-second or low single-digit seconds, and I want to be able to query that data in sub-second time, right? So this is like what I mentioned about is powering real-time dashboards like ad bidding, which was one of the original use cases that StarRocks was built on, or real-time dashboards like what Airbnb is doing for monitoring data, right? Or in other situations where you want real-time transportation data, or any of those type of use cases from that standpoint. Now, one thing caveat I wanted to go say is that the real-time analytics in this piece is really on internal tables. However, we do support merge on read Hudi tables. So that's where merge on read, you can get semi-real-time analytics, right? Semi-real-time feeds. So we do support that in StarRocks. Right. Just to give you a little eye chart on performance, this is TPC results. You guys have probably seen TPC results from many, many different vendors, right? And so this is us with StarRocks, not using our internal tables, connecting to an external catalog, right? So this is one of those table specs that I mentioned in the previous slide, right? With cache block on. And you can see when we go across as the TPC results, we're 3x to 50x times faster. And that's because we're a traditional data warehouse in that sense, right? We do cost-based optimization, we do SQL query planning. We also have this thing called SIMD, which is single instruction, multiple data. It's a way for us to be able to do multiple operations within one CPU clock cycle. That makes it much, much more faster from that standpoint. And the cache block is essentially for us to cache a lot of the results once it comes into the database system, right? And I'll show you this in the demo. So you can actually see the differences when cache block is turned on. And you can see the difference in speed. So let's get to the demo, right? So we have a demo here of StarRocks with Apache Hudi. If you have a camera right now, you can follow along on the QR code. The QR code will send you to a tutorial we wrote off of GitHub. And basically the idea with it is that you're going to go and basically do the Apache Hudi quick start, right? So if you've ever done it, it's the Docker setup that you have, right? It uses Docker Compose and it spins up a full Hudi environment. We're going to modify that default YAML and add is the StarRocks image into that Docker Compose, right? So now that the Docker Compose, when we started on up, it'll actually load up the StarRocks environment alongside all the Hudi containers that are there, right? Then we're going to go do the Apache Hudi quick start. So the quick start, if you've done it before, is like you load some data through Kafka, and then you actually go and ingest the data, and you actually make a bunch of different tables. One is the COW, the very common, create on write, and then you're actually going to see the merge on read tables from that standpoint, right? And then once you're done with the Hudi quick start, we're going to go and then log into StarRocks, add the Hudi external catalog, and then actually query the data. So that's the demo. So if you've got the quick start, you're like 80% all the way there to go and do the demo that I'm about to show, right? All right. So I'm going to bounce out a little bit here, right? So if you've done the Apache Hudi quick start here, you kind of know from that standpoint is that you first go and clone the Hudi project, and then you start at the demo cluster. So I'm going to start up the demo cluster here. Right. I'm using the newer MacBooks that are not Intel based. So that's why I'm going to use the switch to go and do the Mac.
Albert, do you want to make the terminal a little bigger? Yeah, like
yeah, sure.
plus. Yeah, thanks. More bigger. Yeah, I think it's still kind of small.
More bigger.
Yeah, better. Thank you.
Yeah. All right. So it takes a while, as you know, to take all the containers on up, right? Let's see here. You can kind of see here, it's starting on up, right? 40 seconds ago. There are a lot of containers in the quick start, but you guys kind of know that it's pretty cool because it's a full Hive environment with Hudi on the back, right? So it's pretty cool. All right. So now we've got the container set on up. So what's the next thing you go do, right? So it says here, you're going to go publish a bunch of items into Kafka, right? So I already got that here, right? So that will go and pipe in a bunch of stuff. Let's query it really quick. So great, there's now some topics in the system, right? So that kind of gets me past this section, right? Now I have to log into the Docker container and have Hudi ingest the data. So log on in, right? Run this Spark job, right? This does the COW, right? And then there's going to be a second job that's going to create the merge on read, right? So nothing special here. I'm just copying and pasting straight off of the Hudi quick start, right? And then I can throw up a browser here. And voila, you can see now it created a bunch of data, right? The timestamp matches today's timestamp, right? So that's the COW, and here's one for the merge on read. So merge on read, you can see a bunch of data here, right? And then the next thing you got to go do is now you got to sync that data with the metastore, right? So great, got one synced. We've got another sync for the merge on read, right? And now you should be able to run is SQL, right? So now I can run the beehive. And I can go show tables. And now I have all the various tables. And I can then go do like a select count. right? So I'm going to do a select count, right? And see, there's 170 records, about 3 seconds, right? And if I run it again, it kind of drops a little bit to about 5, right? Because now the results are a little bit more cached, right? All right, so great. Now we've loaded data into the system. Theoretically now is that you have a Hudi environment with a bunch of data in there. So let me exit out of this, right? And now let's go over to, oh, I forgot to show you, right? So the part where I modified the environment, right? So if I go to compose and I VI the Docker, the Mac YAML, right? What I basically did was that I added this section. So this is the only thing that I modified in the Docker Compose, is that we have a special Docker image that's called our all-in-one. Basically, the real architecture, we separate the front end and the back end. So the storage nodes from the query nodes from that standpoint. But in this situation, we have is an all-in-one image. And I just inputted this one line so it would run it alongside in the same Docker network as all the other Hudi quick start containers, right? And I just then mapped ports. All right, so let's go back. All right, so let's go and now run is the SQL commands, right? So here you can kind of see I'm just using normal MySQL client, port 9030, which is what the port that we go use. It's on localhost because it's with the rest of the Docker containers, right? So if I go show catalogs, I only have is the internal catalogs. That would be to our internal tables, right? And going to now my tutorial, right? We've already done is create the Hudi environment, add the Docker image, we queried Beehive, we got the data that says 197 back, right? So now I need to go and at the external catalog. So the first command is basically create an external catalog, and I have to put in that it is Hudi and my login information and whatnot. And the second command is basically now setting my default catalog to be Hudi and then use the default tables that are in there, right? So if I execute this, all right. If I show tables, I actually see all the tables from that standpoint. You can see it's the same 3 tables that we actually did on the Hudi side, right? Now, I'm going to run this next command, which is going to go and do a count. Now, it's going to show an error, and the reason why for that is it's something that I have a PR for. We got to fix it, but I have to do a refresh command. Refresh. So I have to refresh the external table. That's only because I've got a PR that I still need to go and submit into it. But once you go do that, you can now go and query, just like the same thing as the stock ticker count, right? And you'll notice that it took 119 seconds. So it's a little bit faster than when I did the Beehive. But if I run this again, now its query block is enabled. And so now it drops to 0.1 second, right? So think about it, 3 seconds. When I was doing it a Hive, it was like 3 sec or Spark, it was like 3 seconds, ran a couple times, and it went down to 1.5 seconds, right? Then in StarRocks, even just out of the box, it's 1.2 seconds. And then when query block is now caching the results, now it's down to 0.1 second, right? And I can also do this for the other tables that I have, right? So let's go do it for, like I mentioned here, we got show tables here. So let's do the select also, right? Stock ticks more, RO. Also know that I have to refresh the table again, right? So it's going to give me this error. That's okay. Refresh the table. Whoops. Right. And then I can also run it, same thing. So this is now on the read on merge, right? And you could kind of see also that it's also because some of the data is cached, it also drops now even to be lower than 0.1 seconds. So that's it. That's all you had to go do. So if you have a Hudi environment from that standpoint, right? If you do have a Hudi environment, all you have to do is just put in a couple commands from that standpoint to add the external table into StarRocks, set the default catalog in StarRocks not to use the internal tables, but now use the Hudi catalog, right? And just query away from that standpoint. And so you can query flat tables, you can do joins from that standpoint, right? We also have the ability for you to go and do things like materialize views, right? It's a little bit still under testing, but our goal here is we've got it in alpha of doing materialized views in terms of batch, right? So let's talk a little bit about futures, right? So now that you saw it's really easy to add on, I'm going to get its fast queries. I don't have to learn Spark. I can just use SQL from that standpoint. I can do joins from that standpoint. Like, what else are you talking about, Albert? What else can we go do that, we've talked about how StarRocks is fast, fast, fast. So in terms of futures, right, we have no dates on this, but right now we can only currently read, right? Read on various different types of tables. You saw that on COW and also on MOR tables, right? We're in the process of supporting writes inside of Hudi tables, right? So that way you can have single source of the truth on the lake while getting that single digit or sub-second data freshness from that standpoint, right? That's a big ask from a lot of our community users. Our next thing, or the other thing that we're also working on too, is that we only support batched and scheduled materialized views for Hudi, right? And so if you're using MOR tables, you're probably going to get more fresher data by just doing those queries directly against the MOR tables. So in this situation, this is where we want to get that types of parity on materialized views. And our eventual end goal here is that we want to be able to provide materialized views in a hybrid way. So say, for instance, you want to do materialized views on internal tables and on Hudi tables and one of the other table specs that are on out there, right? So you can do materialized views across all those different table specs, wherever they're at, and get sub-second refreshed data on those views. And what does that mean? Easier pipelines, you can support joins, you don't have to go and you can do transformations inside of the database from that standpoint, right? Instead of you have to doing all this, like, you know what I mean, pipeline engineering that goes on all over the place, right? So that's it. That's it, what I have to show you for today. You can find the presentation off of our this bit.ly. We also have a free cloud tier if you want to go use. It's free. Free as in you can go use it for free or use our VMs for free. So CelerData provides is a managed service offering. That's why we can go and provide that. If you want to go stick with the containers, the StarRocks containers, like what I did in this demo, feel free to go do that. But if you wanted to go and see the cloud service, it's out there at cloud.celerdata.com. And if you have time, please join our Slack channel to find out more what we're doing with Hudi. Would love to go and see you there. And yeah, feel free to ask questions.
I think, Poe, if you want to unmute yourself, I think you have some questions. Or is Poe there? Oh, maybe he dropped. So Poe had a couple of questions. One of the questions he asked is, which data catalogs does StarRocks support?
Yeah, so we support the 4 major data lakes, right? So Hudi, Iceberg, Hive, and Delta Lake.
And then the other question he had was, can you query real-time, merge on read, real-time views?
The views part, I haven't necessarily tested yet. I've got to go and look back at that. But that's a good question. I'll definitely, if Poe, if you got my info, so and I'm also on the Hudi Slack instance, just message me, and I'd be happy to go and find you that answer.
Yeah, I'll make an intro. No worries. I'll leave it open to questions. Please unmute yourselves and feel free to ask questions.
I have one question. So this is Aditya. Like this good query performance, have you tested with a larger data set? And does it runs on a distributed system under the hood?
Yeah, so let me answer the second question first, right? So does it run on a distributed system? Like, so for the demo here, I basically had a all-in-one Docker container, right? In the real environment, it's more, we recommend, say, for instance, we have this front end and back end architecture. So as you can imagine, we use something like the RAF protocol, right? That's why everything's in threes, right? Threes, five, sevens, right? Prime numbers with the exception of two, right? And so what we go do is that if you're talking about our smallest, I would say production cluster, typically it's 3 front end nodes and 3 back end nodes. And the back end is all replicated, right? So that if one node goes down, data is still available for you to query on nodes 2 and 3, and for you to have quorum, right? And as the cluster gets bigger and bigger, then you can go do more, replicated nodes. You can do more copies of the data from that standpoint. Architecturally wise, we are not scatter-gather, we're MPP. So that's why this kind of having data replication on the back end, and for us to know where the data nodes are all at, or for that piece of replicated copy, we can go to multiple places to go and query that data. So I hope that answers that question a little bit about architecture and distributed, right? So our largest customer, community customer that we know of, has 1,000 nodes on their back end. It's pretty big. We have an upcoming video on the StarRocks channel that talks about this in detail. That's being done it's being recorded during this time. And then going back to your first question, you kind of dropped out a little bit. Could you repeat the first question again?
Yeah. So we were comparing the Beehive query and the StarRocks query, right? But it is for a very small data set. So
Yes.
a lot of extra overheads will be there, right? So what I wanted to ask is, this query performance, does it scale linearly along with the data?
Yes.
What I meant is like, yeah.
Yes. Yeah. So the question that you asked for is like, okay, Albert, you showed me a grade on like basically a query on only 100, 200 rows from that standpoint. What about if we had like billions of rows with billions and doing a join on billions from that standpoint, right? So we actually have is a blog entry off of StarRocks.io that we did actually more TPC data, right? So the TPC data that we had up for this one was only 1 terabyte. We actually have ones of different types from that standpoint. And then you could see actually like where we're doing billions of rows joined with other billions, joined with another millions from that standpoint. And you can see the performance. But we pride ourselves at low single digit, if not sub-second response times for data that's within our database. And when I say within our database, that is a statement of saying, on local tables, on internal tables, and on external tables, external catalogs like Hudi. So this is actually Hudi data from that standpoint.
Yes,
And this was against Trino. I think a lot of you guys probably know what Trino is, right? It's another database in a similar space, right? So
Sagar had a question. Sagar, do you want me to repeat the question or do you want to ask it live?
Yeah, I can go. Yeah, Albert, this is Sagar. First of all, awesome demo. I was more curious about the cache. What does can you talk a little bit more about the internals of the cache? S- uh, so you can check my question. Basically, I'm looking for, say you had a bunch of Parquet files, and these are all 100 MB plus Parquet files for TPCDS tables. What does the block cache do? Is it further uh, caching smaller and smaller blocks? What's that block size, default block size? And can someone, depending on the query, does the plan prune which block needs to be scanned? So I'm just trying to make sense of the drastic improvements that you're showing here.
yeah, so I would say I would summarize it more more high level than that. I would say that this cache blocking happens more in the query engine layer, right? Not on the storage side, right? So once, you know, as you can imagine, a query comes on in, and then we go through CBO, the cost-based optimizer, to rewrite the query as we see fit, and then we pull the data from the S3 buckets, right? And then it passes back through eventually to the client, right? As it passes back through to the client, right, that's when we start caching some of these results, so that when you go back and execute this query again, right, the CBO knows that there is some data that we can re-leverage from that standpoint, and then use that as part of the response, right? So you know, I think this is much more of a traditional database caching from that standpoint, right? This is not something that is a cache for specifically for Hudi, right? On the storage level.
Yeah, I get it. Not just for Hudi, but any Parquet data
Yeah,
set as such.
yeah. But it has to run through the system first, right? It has to run through in order for us to go and cache it.
Okay, all right. And how do you explain the uh, so this caching will take effect on the second attempt of running that query. The very
Yes.
first attempt, is there some additional metadata that is maintained which helps in improving the performance when you compare it with Spark? Like 1.19 seconds versus 3 seconds, that difference, how do you account for that?
Yeah, so okay, so this comes back to the specialization that StarRocks has, right? So I kind of mentioned this in the beginning of the video that we talked about performance, right? So there is a feature that we use in the CPU called SIMD, single instructions, multiple
Okay.
data, right? And if you're familiar with this part of the CPU, right, it was originally designed to go and do things like modifying, say, for instance, the volume in a game, right? So you wanted to go, instead of you individually moving, you know, various like notes up one octave from that standpoint, doing a big for loop, you do a scalar operation that does it all as one operation, right? They do this also for games where you do like lights inside of the game and other types of video movement, right, from that standpoint. So what we did was that we implemented this type of, so first of all, it was a theoretical academic paper of applying this type of technology to databases, right? And we are one of the few databases that took this academic idea and actually implemented. So this is how we get so much performance, because in one CPU cycle, you typically do only a read or do only a write. And now we can stack inside of that same CPU cycle multiple reads, multiple writes, right? And so that's how we get that performance. So where I kind of allude to this, and to simplify it for a lot of people, especially for non-engineers, it's like you doing algebra and I'm doing linear algebra. It's just like I'm working on matrices, you're working on a single element row, right? And this gets us the performance, and it works for OLAP databases because we typically do operations on a range of data. This doesn't work in OLTP systems because you're only doing it on an individual row, right? An individual record. So you cannot get this scalar operation, right? Unless you're actually doing a mass update of something, right? Or a mass insert of, like, I'm just changing everything like $100 more, right? From that standpoint. But especially for OLAP systems where you're trying to do roll-ups, and you're trying to do, large, like, restructuring of the data from that standpoint, this is a really good use case for using those parts of the CPU, right? And that's why we fundamentally get, a much better performance, assuming everything else is the same, right? I mean, all databases have a CBO, right? All databases have some type of query, acceleration from that standpoint. All of us do caching from that standpoint. So what makes us truly different, right? It's how we implemented the SIMD.
Got it. Yep. Thanks. Are there any blog posts about this?
There is. Most of it is academic papers. So you can feel free to read about it. And there's other things that we that we borrowed, right? So we have, like, on we also support, like, for instance, primary key, right? And that we borrowed that from Microsoft SQL Server, right? So there's other enhancements that we've done along the way, but I would say the SIMD was the big thing. And I can only count on less than one hand the number of databases that actually implement SIMD that we know of.
In that sense, Hudi also maintains a record key. Does that help StarRocks in any way?
Can you
like among all these Lakehouse formats, Delta, Iceberg, and Hudi? Hudi. So as far as I know, Hudi is the only one which has this notion of primary key. It's called Hudi record key.
Yeah.
So I was just wondering if this is also used in StarRocks.
Yeah. So as you can kind of see in the demo, right, was that we just connected to Hudi's catalog, right? And so we just import whatever metadata structure they have on the tables, on whatever else that they're able to go provide, right? So, I think that question where you're asking about is, do you support or not support certain features, right? We're leveraging the Hudi libraries for us to access those tables. So it's really what the Hudi provides. So if, say, for instance, Iceberg provides as a specific thing in Iceberg, right? We're just going to go and use the Iceberg libraries to go and interact with that catalog, right? And pull out whatever information we need to go do from that standpoint, right? So what we would expect is that if Hudi built something new inside of for Hudi users from that standpoint, because we use the libraries, we'll just naturally inherit those abilities from that standpoint, and we'll add on top of it the cache block and the query engine and the cost-based optimizer, right? All those things, the vectorize the engine, right? All that other stuff we'll add on top of it, but we'll also do it for all the other table formats too, right?
Yeah. All right. Yeah, thanks.
We have another question from, I believe, Do you want to ask your question, or should I repeat it? So he asked, does StarRocks queries run faster on Hudi, and why?
Does StarRocks queries run faster on Hudi, and why? I would say that because we treat all the four different data lakes equally, right? We essentially go and connect to the external catalog right? We inherit their abilities. So the performance that you're really gathering or you're getting is really underneath from those table format specific implementations, right? And so I think what you're going to go get is it's going to be a depend statement, right? Depends on what you're storing inside of Hudi versus, you know, maybe against Iceberg, right? You're definitely going to be better than Hive. I'll tell you that part. You're going to definitely be better than that, right? but against those two, I mean, there's a lot of engineering, and they all have all the other three have a lot of engineering, and they all have different quirks with them, right? About which one that they're spending more time in. So I would say it depends on your use case, right? If the ask here is that, do I have a similar demo with Iceberg? Yes, I do.
Hey, Albert, thanks for answering the question. I think there are actually several questions embedded in this one. First is, as you said, it could be implying a comparison between different Lakehouse catalogs, right? Suppose they run similarly, maybe. There's another side of the questions. So if we run StarRocks query just by itself on StarRocks without any catalog, how does that compare with the running on Hudi or some other?
So it is a question here is if we compare internal tables, right, versus external catalog with Hudi tables, which one is faster? Is that the question?
Yeah, this is part of it.
Yeah. So in our internal testing, internal tables are even faster, right? Okay. And the reason why is because we don't have to pull from a remote S3 bucket, right? And we have, you know, local attached disk or network attached disk, right? Either an EBS volume that's, you know, in the AWS world, the EBS volume that's attached to the instances, right? So you do get better performance, but then you get the problem of like copying data, right? So a lot of people, what they go do is they select and insert in to the internal tables, right? Or they use Spark, or they use Flink, and then they you know, populate the StarRocks internal tables. I tell people, right, our goal here at StarRocks is to get parity as much as possible, right? So whether you use internal tables or you use Hudi tables, right, our goal here is that we're not going to treat one better than the other. We're going to try to treat them out equally, but there are just physics problems, right? How fast data can come out of S3 buckets, right? Versus how fast that you have is some SSD that's attached to your VM, right? It just is, right? It's a physics problem. It's not.
Yeah, definitely. That's understandable. So, can we query external table directly without help of any catalog? Just
so
residing on S3, yeah.
Right. So the question becomes is like if you can go connect to an external table without a catalog, right? So we used to be able to do that. And there is documentation, outdated documentation on our website that talks about this, but we deprecated a lot of that, right? We really do need that catalog.
Okay.
And so I highly suggest that because the catalog is not just data from that standpoint, right? It also has like a lot of other, you know, companies or a lot of other open source projects are building maybe a security layer on top of those. And so it's going to be valuable, right? That the catalog is going to be more than just table structures. Okay,
yeah, sounds great. So what other benefits can we get from using Hudi or Iceberg or something else, like this kind of catalog?
Yeah, I think the big thing that you're going to go get is that in the situation, if you really believe in data lakehouse, right? Data lakehouse architecture, right? I mean, the whole idea here, especially even our idea of data lakehouse, is that you want warehouse-like capability on top of data lakes, right? On top of S3 buckets, right? Data that's stored in S3 buckets, right? And with the ability of something like Hudi, right? If data is stored in Hudi, theoretically, right, you can throw away and take another query engine like Spark or Trino or whatever, and you'd be able to say, I don't like the performance of StarRocks. I'll throw that query engine away, pick another query engine, and then connect directly to the catalog and start querying data, right? That's theoretically the value, right? And we have a lot of community customers or community users that really believe in that vision, right? They believe in the vision that Hive is kind of deadish, right? It's kind of like it is good in certain use cases, right? And the new hotness or the new way to go store data now is through Hudi and through other table formats that are on out there, right? And then it becomes, okay, I move all the data. So now I move all my data out of HDFS, and now I'm in these S3 buckets. Then it becomes, who's going to provide me the best query layer experience, right? Is that going to be Spark? Is that going to be Photon? Is that going to be, you know, Trino, right? Or is it going to be StarRocks, right?
Okay.
Gives you a lot of options.
So another follow-up question. So in your presentation, you mentioned that you currently can only read from Hudi, right?
Yes.
Is something like a write into the table, is something coming up soon?
Yeah, that's in our futures, right? That's the one I was talking about, product ideas, right? And we can only read now. The futures, we want to do writing, right?
Yeah.
So I have no ETA on this, right? This is a thing that the community has to go and vote on up from that standpoint. I just did a survey a month ago, and I need more people from Hudi to vote it up, right? I got a lot. To be honest, I got a lot of Iceberg people, right? So I would love to see the Hudi people out in force on our Slack channel, the StarRocks Slack channel, and say, I need Hudi. I want Hudi rights. I want Hudi viewability, right? I need you guys to make some noise.
Okay, definitely.
We'll
So
to invade the community, don't you worry.
yeah. So is the same thing happening to other catalog support in StarRocks? Are you able to read from all the catalogs, but write is sort of deferred a little bit?
Yeah. So right now across the board, it is reads from that standpoint.
Okay, I see.
And we're deciding where we're going to invest in the write ability. And to be honest too, it's like we want to get to writes, right? It's a question about prioritizing like community committers, right? And companies that are willing to pay for or invest in the engineering, right? We welcome commits from the community, right? And we want that interaction, right? I mean, show it by you care, right? Show it by commits, show it by, you know, asking for these things on channel, by, you know, writing articles, right? Because we're kind of moving where the community wants us to go move, right? I can also tell you a little bit that among the 4 data lakes, definitely what's lagging is Delta Lake. Like, I have very little people who ask me about Delta Lake support, right? But definitely, you know, I would say Hudi and Iceberg are definitely the most talked about.
Yeah.
And along with Hive, right? Along with Hive, because everybody's coming from there.
Okay, thank you.
Yep.
Thank you for your question, June. I think we have time for one more. And this comes from Siva. Siva, do you want to ask your question or should I repeat it from this?
Yeah, I can take.
Sure.
So there are two questions. First one probably should be straightforward. So how does the cache invalidation happen? So let's say if there are repeated queries issued, but in between these two invocations, let's say the underlying system had new commits. How does StarRocks invalidated the cache? Is it lazy or real time?
Yeah, we do both. And it depends on the situation, right?
Okay.
But the idea there is that we don't want to go and give you bad data, right? I mean, that's the ultimate goal, right? It is a work in progress. We do write test suites against this to make sure that it is. We have some customers that are doing like a gigabyte to 10 gigabytes per minute in terms of writing. And then they're trying to read from the same, same queries from that standpoint, right? To see if like how the data is, right? So far we've been fixing, issues as they appear, right? But I can't give you a definite because you know how it is. It's kind of like we're, the code changes so fast. Our goal here is that we don't want to give you bad data, right? And we understand like, caching is not necessarily a brand new thing, right? Everybody wants is like fast results. Yes, use cache. How do you make sure that the cache is fresh, right? Do you do an asynchronous or synchronous process to go do that, right? We do both, but is there situations, edge cases that we might miss? Sometimes, right? So this is where we need help from the community to kind of say, hey, Albert, I'm doing this load, this query, these are the things that you guys are missing, right? And we'll fix it. But for the most part, dude, if we got wrong data to our community users, they would abandon us.
Yeah, I know that. Yeah. We also, so I come from Hudi camp. We take data consistency issues very seriously in general.
Yes.
Okay, one follow-up on similar question. So let's say in between these repeated invocations, the underlying, there is a new commit to the system, but then it is not impacting the query. So let's say there are 1,000 partitions and the query predicate is polling, let's partition 1, partition 2. The new commit is only touching, let's say, partition 10. As a caching layer intelligent enough to not actually do a refresh, but still serve from the cache itself.
Yeah, I want to say yes on that, but no on the materialized view.
Okay.
Yeah, the materialized view is much more difficult to go fix, right? To have a consistent view, right? Especially on the transaction lock level, right? But on caching, I'm pretty sure yes.
Okay, sounds fair. So you do intercept the commit metadata or something to see that, okay, if the query predicate has any impact to it or not.
Yeah. And I would also say that, it is like, there's still optimizations that still need to be made, right? I mean, like most things, our product from that standpoint is like, we understand like SIMD is like our core feature of our query engine, right? And we've built it, right? But then the thing is that due to maybe, a customer demand or due to a new set of commits, right? We may re-architect or redesign a whole section of query code. And maybe we miss that, right? In terms of the cache invalidation or partitioning strategy, right? The algorithms that we use to go and do it, right? So I want to say yes, but the thing is that also, if you look at how many commits we're getting every single day, it's kind of like saying, like, it's very hard for me to go and say, I absolutely checked every single commit to make sure that it doesn't happen, right?
Okay, got it.
Right. But our goal here is that, yes, we want to go and provide that data consistency, because what our use cases that people ask us to go do are things like ad bidding, right? So you got to make sure the numbers are right. Or even the thing is like some type of threat analysis or what threat like dashboard or monitoring dashboard. Yeah, obviously those use cases are not as time and the data is not as important. But our goal here is, yes, we want to go and do it. That the other ones that I know that are more time sensitive are ones where money is involved, and in those situations, when they're using StarRocks as a database, right? We do put a lot of emphasis on it because we know that is their use case.
Okay, sounds good. Just one last question. I know we are pretty much there. It's more like a product question. Have you come across use cases from users? Let's say someone is building a dashboard, not very real time, but let's say they run the query once every, let's say 10 minutes or something. Are there use cases where they say that, okay, even if the data is stale by 1 minute, it's for me, the latency is very important. So it's okay to serve the outdated from cache while the cache is getting synced up with the latest set of data, rather than taking a hit on the latency. Or everyone is like real time, I want to get the latest set of data.
We tend to focus on customers that want the latest data, right? And so we support when we do, like, say for instance, a primary key, or we're doing real-time updates, right? We do delete and insert, right? So we basically tombstone, and then we do an insert on top, right? So that way you can have as a refresh data, and from the view is that you're able to go and see the freshest data first, right? So I would say we optimize for those use cases. It's not to say we can't do the latter one that you mentioned. It's like, just show from cache while the background is being updated. But that's also architecturally a little bit more difficult. You know what I mean? Right. It's this idea that you're going to have to eventually get syncing for these two, that the real log view versus the real transaction log view versus the view that you're currently seeing, right? But I think for us is that if we can go, what we typically do with customers is, or community users, we tell them like what's your ingestion rate, what's your query patterns, and so that we can design the partitioning of the data correctly, so that when you do the ingestion, we can do it ingestion. I think we did, like, one of our community users is doing like 10,000 loads every second, because every partition was one of their customers or something like that. It was something to that effect. So they wanted to do like 10,000 every single time, and so it was a way around some of the issues that they perceived was what they wanted to go design, right? Ultimately, I think a lot of it is a depend statement. I always say, like, first of all, is like, do you have a real-time analytics use case? How fresh do you want the query? How fast do you want to do the ingestion? And then how fast do you want the freshness to go happen? And given that kind of base understanding, then we can go and help design how the table structure should be, right?
Yeah, got it. Okay, cool. Thanks for that. Thanks a lot for clarifying.
Cool.
All right, I think this wraps it up and brings us up to time for the community sync. Please join us next month on the upcoming community sync, and I'll share those details later. And Albert, thank you for the presentation and with StarRocks and how you can query Hudi data with StarRocks.
Well, thank you for having me, Nadine.
All right, everyone, I'll catch you later.
All right, bye.